continue with the equations of a straight line, and we're on part 6, or what I can call lesson 6. We are going to look at the parallel and perpendicular lines. Due to the time and whatever the length of the video, I would like to go direct straightforward. Parallel lines, they have the same gradient. So if you have the gradient of one line, maybe m1, the gradient of one line m1, and the gradient of the second line m2, so it means that m1 is equal to m2. They have the same gradient. Then we have the second plate, that is perpendicular lines. And perpendicular lines are called direct. Perpendicular lines, if you get the gradient of the first line times the gradient of the second line, you get -1. Or someone can say m2 to get the second gradient is -1 divided by the first gradient, where m1 and m2 are gradients. So that's parallel and perpendicular. So parallel lines, they have the same gradient. Perpendicular lines, these are the two conditions we can borrow. So let us start with parallel lines. So if line AB, this is line AB is gradient m1, this is line KL is gradient m2. So line AB and KL are parallel. That means the gradient of AB is equal to the gradient of KL. So m1 is equal to m2. Then the second case, that is perpendicular lines. Perpendicular lines, we have line AB and line AB, and line with gradient m1 and line KZ is gradient m2, whereby they have this arc of 90 degrees. So line AB is perpendicular to KZ, to line KZ. So AB is perpendicular to this, since they make an angle of 90. Therefore m1 times m2 equals -1, or m2 equals -1 divided by m1. So this is also the condition of parallel. So we have a question here which says find the equation of a line. Find the equation of a line which passes through the point -3, 5 and is parallel to the line this. So this is a line. So you have ever seen such lines. If you get such lines, you have to make it in the form of, so we first make this line 2y plus 3x plus 7 equals 0 in the form of y equals mx plus c. So from there we can identify the gradient. So now we can have 2y plus 3x plus 7 equals 0. We take this one the other side, it will become a negative. Take 7 the other side, also becomes a negative. So we shall have 2y equals -3x minus 7. Then from there we know the division. We divide by sides by 2. So y equals -3 over 2 x minus 7 over 2. So that is the equation. So here our m1 will be -3 over 2. Since this one is in the general format of y equals mx plus c, so c is -7 over 2, m is -3 over 2. So this is the gradient. But we know parallel lines, m1 is equal to m2, so they have the same gradient. So we shall get m2 as -3 over 2, and the point from the question is negative 3, 5. So you can use the substitution or any way. So you can say, if you consider this with another point, any format you feel like, but you can use to substitute. So we substitute in y equals mx plus c. So if we are substituting in that, y equals mx plus c, we shall get from here y equals mx plus c, where y, this is x, this is y is 5, m is negative 3 over 10, x times negative 3 plus c. So this is 5 equals negative times negative 9 over 10 plus c. So we take this one this side, we get 5 minus 9 over 2 plus c. So this one LCM is 2. So LCM is 2. 2 divided by 1 times that 10. 2 divided by 2 9. So c equals 1 over 2. Therefore, the equation y equals the gradient, which is negative 3. So therefore the equation is y equals the gradient negative 3 over 2x plus c, which is a half. That is the equation for the straight